Hi everyone, this is Ms. Tom with another lesson on exponential functions. This time we're going to be examining them a little bit more with lesson 8.1.2. By the end of class, students will deepen and extend their understanding of exponential functions by examining the equation y is equal to a times b to the x power. So in the past two lessons, we've actually gone over exponentials with simply y is equal to b to the x power. And the reason for that is because I wanted to emphasize what would happen. It's a curve. We notice it's a curve. It increases when the b value is greater than 1. But when the b value is less than 1 but greater than 0, we notice it decreases. The thing that all of these things have in common is their y-intercept. Their y-intercept is 0, 1. So we'll notice that when we see this equation here, if I put in a 1 as the coefficient, does it change anything? Did the graph change? Oh, it did not, because there is an intercept of 1 each time. So what we're going to do today is we're going to analyze the situation of what does an exponential equation look like if the intercept is not equal to 1. So let's go back to our notes here. So let's go over the rabbit example that we had earlier from the previous lesson. Remember when we said that we started with 2 rabbits? So I'm going to start with 2 rabbits here. Then we noticed there was a pattern. There happened to be 6 rabbits here, so we multiplied by 3. So we had 2 rabbits that got multiplied by 3. And then we continued. Oh, this one was 18. So then we multiplied by another 3. And then what we should have noticed, what we noticed in the last example, was we saw, okay, if we're starting with 2 and we keep multiplying by 3, the equation would be this. We started with 2 and we kept multiplying by 3. So 3 in this case only had 1 3. 3 in this case had 2 3s. So if we don't know how many months there are, we would call it x months. So this is what we had as our equation. So let's go ahead and analyze this rabbit equation here. We're going to notice 2 ended up actually being what? That was the point at which the months was 0, also known as figure 0 or the y-intercept. And then the 3 ended up being the multiplier. That's how many times the rabbit growth was increasing for each month. So let's go ahead and contextualize that. What does that equal to? When you say y is equal to a times b to the x power, what's happening? Well, a, as the rabbit example starts, is the y-intercept. All right, so it's the y-intercept, also known as when x is equal to 0, what is y equal to? And what does b represent? B represents the exponential portion. It represents what's being multiplied, also known as the multiplier. So let's go ahead and analyze this by clicking on this Desmos link. What you'll notice is we've got the equation y is equal to a times b to the x power. When you move a with the slider tool, you're going to notice it moves upward where the y-axis is no longer 1. It is still exponential because it's still curved, but now the y-intercept is 0, 6. See that? So all that happened was we moved the y-intercept because the a value was changing. Now what happens if the b value changes? If the b value changes, the line simply gets steeper if it increases and then decreases when it gets less than 1, just like we noticed. So this equation y equals a times b to the x power is used for when exponentials do not have an intercept of 1. So let's go to analyzing these tables. Let's say you wanted to figure out the growth of your business. And the growth of our business, well, when we have our start date of day 0, and we have $8, let's say we make $8 in revenue, what are we going to notice? Well, first of all, what do you notice? Do you notice a pattern with this? What's happening here? You know what? I think I notice. At first I thought I was adding by 4, but then 8 plus 4 doesn't equal to 16. I noticed, did you notice that we're multiplying by 2 each time? But if we write 2 to the x power, this equation is not really going to give us what we want, right? Because 2 to the x power, if let's say we want to get this one, 2 to the first power will not give us 16. How do we get that value, 16, if this is what we know is being multiplied over and over? Well, we need to have our y-intercept actually there, and that's where we need to make sure we have 0, 8. 0, 8 is our y-intercept, and that actually goes in front here. And the reason why it goes in front is because now if we try 2 to the 0 power times 8, we would get 8 times 1, which is equal to 8, and that's what our y-intercept is. So that means that A is equal to 8 and B is equal to 2. All right, let's continue looking at this one. What do we notice is the pattern here? What do we notice is the pattern here? So we notice, okay, looks like it's being multiplied by 5. Does everybody see that? It's being multiplied by 5. Remember, when you're multiplying by 5, we know that's our multiplier, so we know it's going to be 5 to the x power. However, if you just have 5 to the x power, you're not going to have the table completed. So we need to make sure we include our y-intercept at the very front. So we're going to call it negative 15, 5 to the x power. And this will actually give you the correct answers, where the a value, the starting portion, is negative 15. And when I say starting, I mean the y-intercept. And then 5 is going to be our b value. All right, let's continue on. We notice we have this table here. Once again, what's happening here? How does 9 become 27 and 27 become 81? How do we look at this? Well, if we notice, this is being multiplied by 3 each time. And since it's being multiplied by 3, we know 3 is our multiplier. Well, what is the starting value? What is the starting value of this, also known as the y-intercept? It doesn't have it. It doesn't have it in the equation, the table. So we've got to figure it out ourselves. A common mistake is to write 9, but we don't know what it is. So it's 0. Then we got to figure out, okay, something times 3 is 9. That number is 3. So we know our y-intercept is 3. Our v value happens to also be 3. And we're going to notice that 3 times 3 to the x power is our exponential equation. All right, thanks for sticking with me, you guys. We're going to do one more example, and that'll be it for today's lesson. How do we do this one? All right, so what we're going to do is we're going to graph it. First of all, we got to notice what we see here. 3 times 2 to the x power. I want everybody to write this down. Write y is equal to a, meaning our y-intercept, and then b to the x power, where a in this first case is what? It's 3, and b in this second case, or the exponential multiplier, is 2. So let's go ahead and start where we notice the y-intercept is 3, so we go on this y-axis. Where's 3? 3 is located right here. Then we're going to go, okay, we got to go ahead. We got the y-intercept is 3. But every time this number is going to get bigger by multiplying by 2. So the first value is 3. So what do you think the next value is? 3 times 2 would be 6. And then 6 times 2 would be 12. And then 12 times 2 would be 24, which is way up here. So then all we're going to do is let's go backwards. If you know 3 is where we start, well, half of 3 would be 1.5, which is here. And then half of 1.5 would be 0.75, which would be here. So then let's go ahead and graph our line here, or our curve. What does our curve look like? Looks like this, where it approaches 0 but doesn't equal to 0, and that's our first graph. Woohoo! We got it! Make sure to draw those little arrows if you got it. Okay, next one, let's go over this one. We've got 4 times 2 to the x power. Keep in mind, with 4 with 2 to the x power, we've got 4 as our starting value as our y-intercept. And then 2 is going to be our base value or multiplier. We're going to do the same thing here, okay? On our y-axis, we're going to note where is 4. 4 is here. Then we're going to go 4 times 2, that's 8. 8 times 2, that's 16. If I'm going too fast, make sure you pause, okay? Then we say how do we go to the negative side? Well, we got to do the opposite of times 2. We got to divide it by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. All right, and then let's see, what does our graph look like? Our graph looks like a curve. Once again, the only difference is that our intercept was at a different point. Our multiplier was the same. What happens if we have a value or multiplier that is a fraction? Well, let's figure that out. Well, first of all, we've got to write down what our a value is. Our a value is 4, also known as our y-intercept. Then we've got half as our b value. Okay, so first of all, we're going to go, okay, 0, 4 is here. Our y-axis is here. It's here. Then we go half of 4 is what? It's 2. Half of 2. That's 1. Why am I doing half? Because that's the multiplier. But what if I wanted to go on this value? Well, instead of doing half, I would do the opposite. That's double. So double 4 would be here. Double 8 would be here. So when you notice that the base value is a fraction, we can't actually make it increasing. This is actually a decreasing graph. So I'm actually going to highlight that. Notice our points here. We're going to highlight, go all the way down, so it looks like this. And again, the main difference between these lessons and this lesson and the past lessons was the y-intercept is now no longer equal to 1. The y-intercept can change, and you can see the graphs change as well. Alright, so what I want us to do is we're going to take a look at this closure. I want you to be able to identify what's the a value and b value and figure out what would be the equation for each one. Alright, so this is your closure question for today, everybody. Get this done, submit it, and we'll be ready to go on to the next lesson. Thanks, everybody. Have a great day. I'll see you tomorrow.